Good afternoon, children. Good afternoon to all. How are you, children? I hope you are well. Okay. You have done your everyday work. Are you doing your work every day? Okay. We have completed two lessons. Yes or no? Yes. And the third lesson we started. And also we started the third lesson. In that third lesson, one or two parts have completed. Today, we will study from page number 30, atomic number. What is that? Atomic number. Today, I start from this heading, atomic number. Anu en. Tamilil Anu en என்று சொல்லுவோம். Okay. It is denoted by the letter Z. Atomic number, it is denoted by the letter Z. What is atomic number? What is atomic number? Anu en என்றால் என்ன? What is atomic number? Atomic number is defined as the number of protons present in the nucleus of an atom of element. Okay? Atomic number, listen, atomic number is defined as the number of protons in an atom of an element. Already you know the structure of an atom. Yes, this is a nucleus. In this nucleus, protons and also neutrons are present in the nucleus. Then, in this structure of atom, we studied the shells are there, electronic configuration. That means K shell, L, M, N, like this. Okay. So the first shell name is called K shell. Second, this is second shell. This name is called L. Then third one, that is M. Like that, it will come. Like that will come. Okay. So what is atomic number? First, I told you atomic number is denoted by Z. Is denoted by Z. Now, what is atomic number? Atomic number is defined as the number of protons. This where it is present. Number of protons where it is present in the structure of an atom. It is present in the inside the nucleus. It is present in the nucleus. So, atomic number is defined as the number of protons present in the nucleus of an atom of element. So, since the atom is electrically neutral, so number of proton is equal to number of electron, number of protons. Listen, number of protons is equal to number of electrons. Number of protons is equal to number of electrons. So, what is atomic number? What is atomic number? Atomic number is defined as the number of protons present in the nucleus of an atom of an element. Present in the nucleus of the atom of element. Since the atom is electrically neutral, number of protons is equal to number of electrons. Number of protons is equal to number of electrons. So, the atomic number is represented as atomic number denoted by letter Z. Atomic number is equal to number of protons is equal to number of electrons. Did you understand? Are you listening me? What is atomic number? Atomic number is defined as the number of protons. It is present in the nucleus of an atom of an element. Nucleus of an atom of element. So, the atomic number is electrically neutral. Its formula is, therefore, the atomic number within the bracket is Z. So, is equal to number of proton is equal to number of electrons. Okay, children? Anu en என்றால் என்ன? So, atomic number is defined as the number of protons. That protons present in the nucleus of the atom. It is present in the nucleus of the atom of element. So, that is atomic number. Within the brackets is Z. is equal to number of proton is equal to number of electrons. Okay, children. Now, mass number. Second, we are going to study about mass number. First, we studied atomic number. Now, we are going to study about mass number. Mass number, நிறை எண். What is that? நிறை எண். The sum of, listen, the sum of, already you know. If you are doing maths, when you are doing the maths, sum of following. So what you are doing? We are adding. We are adding. So here the sum of number of protons and the number of neutrons present in the nucleus of an atom of element. That is mass number. This mass number denoted by A. Atomic number denoted by Z. Mass number denoted by A. Listen. So mass number. What is mass number? The sum of number of protons and number of neutrons. They are present in the nucleus of an atom. They are present in the nucleus of an atom. So the mass number within the bracket A. So we mentioned that the sum of number of protons and the number of neutrons present in the nucleus of an atom of element. So this is this mass number denoted by A. So we write mass number A within the bracket is equal to number of protons plus number of neutrons. Did you understand, children? We studied atomic number and also mass number. We studied atomic number and also mass number. Now we are going to study about atomic mass. Atomic mass. Anu நிறை. What is that? Anu நிறை. So what is called atomic mass? The number of times an element, the number of times an element is heavier than 1/12 parts of mass of carbon atom. Listen everybody. The number of times an element is heavier than 1/12 parts of mass of carbon atom. That is called atomic mass. That is called atomic mass. Representation of an element with its atomic number. For example, we take X. We take X. So this is element. This is X element. So that X element has atomic number and also mass number. Atomic number and also mass number. So atomic number we write here. We write here Z. We denoted as Z. Okay. Atomic number and also mass number. What is denoted by mass number? A. So this is A. Now X is X is the element. X is the element and has atomic number and mass number. Atomic number and mass number. So atomic number is Z, mass number A. Are you listening? Can you understand, children? Okay. Now what is atomic number? What is mass number? What is called atomic mass? Now listen. Now we are going to study about isotopes. What is that? Isotope. First we studied atomic number. Atomic number is number of protons present in the nucleus of an atom. Since the atom is electrically neutral, number of protons is equal to number of electrons. Number of protons is equal to number of electrons. Therefore, the atomic number within the bracket is equal to number of protons is equal to number of electrons. Okay. Now, atomic mass. What is that? Atomic mass. Listen, this is the element, X element. It has atomic number and mass number. Atomic number and mass number. Okay. Now we are going to study about isotopes. We are going to study about isotopes. Atoms of same element. ஒரே தனிமம் with the same atomic number. Atoms of same element with same atomic number அணு எண் ஒத்ததாக இருக்கும், சேம். ஓகே, தென் பட் டிஃப்ரெண்ட் மாஸ் நம்பர், நிறை எண் வேறுபட்டது. அணு எண் ஒன்று போல் இருக்கும், நிறை எண் வேறுபட்டதாக இருக்கும். So that is called isotopes. That is called isotopes. Listen, atoms are same element but same atomic number but different mass number. Same atomic number but different mass number. That are called isotopes. Okay. Now, these isotopes differ in their neutrons. Isotopes differ in their neutrons. Most of the elements have more than 2 isotopes. Most of the elements have more than 2 isotopes. Isotopes differ in their neutrons. Listen, isotopes differ in their neutrons. Most of the elements have more than 2 isotopes. Most of the elements have more than 2 isotopes. Since isotopes have same atomic number, they have similar chemical properties. They have similar chemical properties, but they differ from one another. But they differ from one another in physical properties. In physical properties. Okay, children. Now listen. What are called isotopes? Atoms of same element with same atomic number but different mass number. Same atomic number but different mass number. Atoms of same element with same atomic number but different mass number. Okay. Now, number of neutrons is equal to number of neutrons is equal to number of neutrons is equal to mass number what it is denoted by? Mass number is denoted by A. Yes, mass number minus atomic number. Mass number minus atomic number. Atomic number denoted by Z. Listen, isotopes, number of neutrons is equal to mass number with denoted by A. Yes, minus atomic number denoted by Z. Okay, children. Now, listen, some elements and their isotope. Look at table 3.1. Look at table 3.2. Some elements and their isotopes. We will see some elements and their isotopes. Some elements and their isotopes. Some elements. Now we take hydrogen element. Okay, element hydrogen. Now next, element hydrogen. That isotope. Do you know what are called isotope? Say everybody. Atoms of same element with same atomic number but different mass number. Atoms of same element with same atomic number but different mass number are called isotopes. Yes. Now listen. One hydrogen, element hydrogen, that isotopes 1H1. Same atomic number but different mass number. Same isotope, same atomic number but different mass number. So the first, the isotope 1H1, then same atomic number. Yes, same atomic number. So 1H2. same atomic number, but different mass number, 1H3. Now, number of electrons. So, we write hydrogen element isotope 1H1. This is the hydrogen element isotope 1H2. Already we know isotope same atomic number but the different mass number. Here mass number 1. Here the mass number of hydrogen 2. Here the mass number of hydrogen is 3. Okay. So now number of electrons. Number of electrons, that is 1, 1, 1. Number of electrons 1, 1, 1. Why we are writing number of electrons 1, 1, 1? Do you have any idea, children? Do you have any idea? Number of electrons 1, 1, 1. Then number of protons. There are also 1, 1, 1. Number of electrons 1, 1, 1. Number of protons 1, 1, 1. Then number of neutrons. How do we find out number of neutrons? How do we find out? Number of neutron is equal to mass number minus atomic number. So here atomic number 1, mass number also 1. So what is that? How do we find out number of neutrons? Number of neutrons is equal to mass number minus atomic number. So here 1 minus 1. So number of neutrons is 0. Here 1H2, mass number minus atomic number. Yes. So 2 minus 1, 1. Okay, children. This is mass number. This is atomic number. This is mass number, this is atomic number. So all those atomic numbers are same but different mass number. Now we are finding out number of neutrons. How do we find out number of neutrons? From where to where we have to subtract. We have to listen at number of neutrons is equal to mass number minus atomic number. Number of neutrons is equal to mass number minus atomic number. Now 1H3, hydrogen, 1H3. So 3 minus 1. So number of neutron is 2. So we found number of neutrons. We have found number of neutrons. We have to find like this method. So already we know isotopes have same atomic number, they have similar chemical properties, but they differ from one another in physical properties. But they have similar in chemical properties. Next, we'll take carbon element. This is hydrogen element. We have seen. Next, we have to take carbon element. So isotope, how do we write? The isotope? 6 carbon 12. So 6C12. Next, listen, 6C13. 6C14. 6 carbon 12, 6 carbon 13, 6 carbon 14. Here you see atomic numbers are same but mass numbers are different. Here the mass number is 12. Here the mass number is 13. Here the mass number is 14. Now number of electrons. We have to find out number of electrons. Do you know how do we find out number of electrons? What is here? The atomic number is 6, yes. So 6, 6, 6. Number of electrons is equal to number of protons. So here also 6, 6, 6. Now how do we find out the number of neutrons? How do we find out the number of neutrons? Number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. Now, so look at here. Here 12 mass number is 12, but atomic number is 6. 12 minus 6, 6. Okay, 12 minus 6, 6. So the number of neutron is 6. So the number of neutron is 6. Next, listen here. Here the mass number is 13, but atomic number is 6. So 13 minus 6, 7. 13 minus 6, answer is 7. Next, here the mass number is 14, but the atomic number is 6. So 14 minus 6, answer is 8. Okay, children. So we find number of neutrons like this method. We have find number of neutrons like this method. Did you understand this one? These are some elements and their isotopes. Already what is isotopes? Now, atoms of same element with same element. Listen, atoms of same element. Here also say hydrogen, 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 carbon, carbon, carbon. Same element with same atomic number but different mass number. They are called isotopes. You see here, same atomic number. The atoms of same element with same atomic number but different mass number are called isotopes. Okay, children. So we studied some elements and their isotopes. Okay. The next we are going to study about electronic configuration. Shall I rub this one? Electronic configuration. மின்னணு உள்ளமைவு. ஓகே, எலக்ட்ரானிக் கான்ஃபிகரேஷன், தமிழ் வேர்ட் மின்னணு உள்ளமைவு. Electronic configuration. In Tamil word, மின்னணு உள்ளமைவு. Okay. Now, listen the distribution of electrons in different shells. Listen here. The shells revolves around the nucleus. Shells revolves around the nucleus. So here the distribution of electrons. The distribution of electrons in different shells. For example, K shell, L shell, M shell, N shell. Okay, that's why the distribution of electrons in different shells revolving around the nucleus. The shells revolves around the nucleus of an atom. That is called electronic configuration. That is called electronic configuration. Listen here. The structure of look at the structure of atom. Nucleus. Here proton, neutron. Okay. Here this is shell. K shell, L shell, M shell. So the distribution here 2 electrons. Suppose here 3 electrons. So that is the distribution of electrons. The distribution of electrons in different shells. In different shell. This is K shell has 2 electrons. L shell has 3 electrons. That is the distribution of cell. They revolve around. This is nucleus. In protons and neutrons are present in the nucleus. So they revolve around the nucleus. They revolve around the nucleus. That is electronic configuration. The distribution of electrons in different shell, not same shell. This is K, L shell, M shell, N shell, and so on. Okay, children. Now, in all the elements, the shells are filled with electrons. So using the formula 2n squared. Using the formula 2n squared. Listen, using the formula 2n square. All the shells are filled with electrons. Here electrons, listen, electrons are filled in the shells. Electrons are filled in the shells. It will, protons and neutrons will not come here. Only electrons fill in the shells. Okay, the formula 2n square. So all the elements which have 8 electrons in the outermost shell, they are stable and they attain electronic configuration of the nearest noble gas. That is called octet rule. Listen, children. Listen. All the elements which have 8 electrons in the outermost shell. Suppose this is outermost shell. You take this is outermost shell. It should be 8 electrons. If it has 8 electrons, that is they are stable. They are stable and they attain electronic configuration of the nearest noble gas. That is called octet rule. If any outermost shell has 8 electron, should have 8 electron. That is octet rule. Okay, children. Now we will see electronic configuration of elements with atomic number 1 to 20. Electronic configuration of elements. With atomic number 1 to 20. Okay, children. Now listen. For example, element H, hydrogen. First atomic number 1. Element name is, this is atomic number, okay, 1 to 20. Atomic number, this is element, hydrogen element. We take hydrogen element. So hydrogen element atomic number is 1. So that this electronic configuration in shell, listen, electronic configuration in shell K, L, M, N. Electronic configuration in shell. Valency. Next we have to see the valency. This is the column. Okay. Atomic number. What is that element name? Then electronic configuration in shell. Already told you 4 shells K, L, M, N. We are studying. So now the atomic number is 1. The element hydrogen atomic number is 1. So the K shell 1 electron. How many electron? 1 electron. So here we put dash because in L shell has no electron, M shell has no electron, N shell has no electron. So we put dash. Okay. Now we have to see the valency of the element. So valency of the element, that is, listen, how many here? 1. Yes. So that is this valency. The next atomic number 2. Helium. What is that? Helium. He. Helium. So the element, the symbol is He. Name of the element helium. Name of the element hydrogen. The symbol is H. Name of the element otherwise hydrogen. Name of the element symbol H. Name of the element helium. Symbol He. Okay. Now here 2 atomic number. How many atomic number? 2. Helium has 2 atomic number. So here in this K shell we write 2. We put 2. L shell has no here M also and N shell also. Now the valency is 2. The valency of this 2. Okay. Then next third, the atomic number 3. Atomic number 3, lithium. Li. Yes, Li. That is this symbol. The element is lithium. The element is lithium. Atomic number 3. Now we have to see the electronic configuration in shell. 3. So 2, 1. Why we are not writing directly here 3? K shell has here already what is in the previous 2. So here also 2. Then remaining we have to put the next shell. Okay. So now atomic number we have to add 2 plus 1 3. 2 plus 1 3. So here we put dash. Here we put dash. Now we have to see the valency. What is its valency? 1. What is its which is in the L shell? L, outermost shell electron. How many? 1. So the valency is 1. Okay, children. Are you listening me? Can you understand? Okay. The next beryllium. Next one, beryllium. Atomic number 4, beryllium. That is symbol. Symbol is Be. Symbol is Be. Listen. Here first shell, which one comes? Here 2. So here also 2. Okay. Then how many remains? 4 atomic number. So 2. So next we write here. Okay, children. Okay. Now the valency is 2. Which is in the outermost shell? How many electrons are here? What is the number in the outermost shell? 2. So that is its valency. That is its. Here we put dash. Here we put dash. This is electronic configuration elements with atomic number table. With atomic number table. Okay. The next beryllium. Listen. Next B, boron. 5, boron. What is this symbol? What is this symbol? B. Okay. What is this symbol? B. Atomic number 5. So 2. The remaining numbers we put here. Okay. Remaining numbers we put here. So now this valency is 3. Because 3 is in the outermost shell. 3 is in the outermost shell. That's why that valency is 3. That valency is 3. Next, atomic number 6. Atomic number 6. Carbon. What is that? Carbon. Listen, C. Okay. Now, 6 is there. 2. Remaining numbers we put here. 2, 4. So, now the valency is 4. Now, the valency is 4. Next, nitrogen. Atomic number 7. Nitrogen. The symbol is N. Okay. Now, here we put 2. Yes. Remaining number we put here. Remaining number we put there. Yes or no? So, remaining number 5. Remaining number is 5. Now, how do we see the valency? How do we see the valency? Now, 4, we have to write up to 4 we are writing. What is in the last shell, which number is in the last shell? That its valency. That is that valency. We are writing like this. Now, the last shell number is 5. So, what is its valency? If it is more than, listen, if it is above 5, if it is above 5 in the last shell, we have to subtract from 8. We have to subtract from 8. For example, above 5. 5, 6, 7, 8, like this. Okay. Now, above we have to subtract from 8. So, 8 minus 5. What is that? 8 minus 5. So, the answer is 3. So, the answer is 3. Are you listening, children? Are you listening? Otherwise, 5 minus 8. 5 minus 8. Opposite sign. So, the answer is minus 3. So, the answer is minus 3. Got it? Okay, the next, now I will give you two more examples. I will give you two more examples. We are seeing from the atomic number 1 to 7. Now we are going to see 9. 1 to 7, 8. Atomic number 8. Atomic number 8, oxygen. Atomic number 8, oxygen. Element oxygen. Symbol O. Okay. Here you see, it in the previous element 2, 5. So here 2's remaining number here we put. Okay. Listen, sorry. 2 come here. 2 symbol O. 2 come here. 6 come here. Then, now how do we find out the valency? 6 minus 8. What is the answer? Minus 2. What is the answer? Minus 2. Then next, for example, 12. We take atomic number. Otherwise, we will study continuously. Atomic number 9. Now, atomic number 9. Fluorine. What is that? Fluorine. The element name is fluorine. F is given. Fluorine. Element name is fluorine. The symbol is F. Listen. Here 9. Yes. So 2. Here the previous which ends with 6. Previous ends with 6. So 2, 7. 2, 7. Yes. Here we put dash. Now 7 minus 8. Valency. We have find like this. Okay. 7 minus 8. What is the answer? Minus 1. What is the answer? Minus 1. Next, neon. What is that? Neon. Atomic number 10. Element name is neon. Symbol Ne. So here you see in the previous K shell has 2. So here 2. Remaining number come here. Okay. 2, 8. Now, above 5, already I told you, subtract 8. Subtract 8. So, 8 minus 8. Answer is 0. 8 minus 8. Answer is 0. Then next, sodium. We will see sodium. Atomic number 11, sodium, symbol Na. Listen carefully. 11. So, in the previous first shell has 2, second shell has 8. Okay, 2 plus 8, 10. How many remains? 11 minus 10, how many remains? 1. Yes, 1 goes here. Here we put dash. So, how do we find out its valency? If it is below 5, the last shell, how many numbers are there? Our outermost cell, the number of in the outermost shell, that is its valency. So, in this outermost shell has 1. So, that is its valency. So, here valency is 1. Here the valency is 1. Are you listening? Can you understand, children? Okay. The next, magnesium. 12. Atomic number 12. Magnesium. Element name is magnesium. Symbol Mg. So, here you see in the previous 2, 8. Yes? So, 10. So, remaining 2. So, 2 will come here. What is its valency? What is in the, which number is in the outermost shell? That is its valency. So, here 2 is there. So, this valency is 2. This valency is 2. Then next, aluminium. 13. Atomic number 13. Atomic number 13. Aluminium. Element name is aluminium. Symbol Al. So here you look at here 2, 8. Okay. 2 plus 8, 10. Then remains how many there? 3. So we put here. Here we put dash. Now it is 3 is in the outermost shell. So it is its valence. Okay. 3. The next 14. Atomic number 14. Which element name is there? Silicon. Which element name? The element name is silicon. The name of the element is silicon. The symbol of element is Si. So here 2, 8, listen 10, 4 is here, yes? Remaining 4. So the 4 will come. So the valence is 4. Next, atomic number 15. The name of the element is phosphorus. The name of the element is phosphorus. The symbol of the element is P. Now, the electronic configuration 2, 8, 10. Here remaining 5. Already told you if it comes above 5, what should we do? It should be subtract 8. So, 5 minus 8. 5 minus 8. What is its valency? 5 minus 8, what is its valency? Minus 3. The valency is minus, here we write 2, 8, 5. Okay. There we have to change. Up to 8, listen, here up to 8. Here also up to 8. Okay, the next, if suppose n shell, atomic, according to the, based on the atomic number, n shell has also number. If it is more than 8, the next shell will go like this. Okay, children. Now, 2, 8, 5. The next 16th element, the name of the element is sulfur. 16th atomic number 16. The name of the element sulfur. The symbol of the element is S. Now, 2, 8. Remaining how many is there? 16 minus 10, 6. Yes? Okay. Here we put dash. Now, valence is 6. So, 6 minus 8 minus 2. 6 minus 8 minus 2. So, we have to find out like this. We have to find out like this. Okay. Are you listening, children? Sodium, magnesium, like this will come. Okay. The next, take page number 32. All of you take page number 32. Valency shell. What is valency? What is valence shell? What is valence shell? Already we studied valency, yes? So valence shell, which number is in the outermost shell, that is that valence shell. Yes or no? Okay, we will see them. Let us study. Valence shell. The heading, valence shell. What is valence shell? The outermost shell of an atom. Outermost shell of an atom. Already told structure of atom. Yes, this is nucleus. If it is 2 shell or 3 shell, 3, suppose they here 3. So the outermost shell of an atom. This is outermost shell, yes. K, L, M. Suppose N shell. This is outermost shell. So the outermost shell of the atom, that is valence shell. The outermost shell of the atom. Listen, here the electrons. In this shell, the distribution of electrons are here. Yes, electrons are distributed here. Electrons are distributed in the shells. Electrons are distributed in the shells. Next, that is valence shell. Next, valence electron. Valence electron. Valence electrons. Valence electrons. The number of electrons present in the outermost shell. Listen. Here, suppose the outermost shell, 2 electrons. 2 electrons or 3 electrons. This is valence electron. This is valence electrons. Okay. So the number of electrons present in the outermost shell, that is valence electron. Okay children. The next valency. Next valency. Here the number of electrons and element loses or gains or share for attaining stability, for attaining stable configuration, that is called valency. Listen, the last shell, outermost shell should have 8 electrons, whether maybe losing or sharing or gain. Okay, so that is valency. If an atom has its okay, the next we will come positive and negative valency. Valency we know. Next positive and negative valency. Positive and negative valency. Already we have seen in that electronic configuration. Yes, elements with atomic number, electronic configuration. Already we have seen that. During chemical reaction, if an element loses an electron to become stable, it gets positive charge. That is electropositive valency. That element is said to have electropositive valency. Listen, if any element loses the electron to become stable, it gets positive charge. ஒரு எலக்ட்ரானை கொடுத்துட்டு ஒரு எலக்ட்ரானை அது இழக்குது ஒரு எலக்ட்ரானை இழக்கும்போது அது என்ன சார்ஜுக்கு மாறுது அப்படின்னா பாசிட்டிவ் சார்ஜ். ஓகே, ஃபார் எக்ஸாம்பிள் sodium. The sodium has sodium atomic number is 11. Sodium atomic number is 11. Listen here. Now for example, sodium atomic number is 11. So 2 electronic configuration 2, 8, then 1. Yes or no? 2, 8, 1. Now atoms. Sodium atomic number is 11. So I split it into electronic configuration 2, 8, 1. Already you have studied. So this is an atom. You see 3 shells. K shell, L, M. So 1 first shell, K shell, L shell, M shell. Okay, M shell. Now here 2 electrons, here 2 electrons, here 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Here outermost, here already put, here only 1 electron. So, but here 8 electron. So it must lose 1 electron. So this outermost shell has 1 electron. If it loses 1 electron, then only it attains the stability. They should have 8 electrons in the outermost shell. The atom should have 8 electrons in the outermost shell. Then only they attain the stability. Yes. So here this sodium should lose 1 electron to attain the stability. So it is positively charged. If we lose 1 electron, it gets positive charged. Okay children, positive charged. So we say sodium positive. Because it loses 1 electron. Okay, you see there, sodium atomic number 11, electronic configuration 2, 8, 1. Therefore, how many electrons are there? 11 electrons. So sodium plus, how sodium gets positive charge? It loses 1 electron. Electrons. Now 10 electrons valence, 10 electrons. There is 10 electrons. The valency 1. Valency is 1. Okay. Then in case the chlorine element, for example, chlorine element, it will we will put that chlorine element, chlorine atom. The atomic number of chlorine, that is 17. How many? 17. Chlorine atomic number 17. So the electronic configuration 287. Yes or no? 287. So we draw the structure of atom. Nucleus, first shell, second shell, case, third shell, KLM. KLM. Okay. Here first shell has 2 electrons. 1, 2. Second 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Okay. 2, 8, 7. 7, 8. The next, the outermost shell has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Only 7 electrons in the outermost shell of the chlorine atom. In the outermost shell of the chlorine atom. So, it will gain 1 electron. Listen, only 7. It needs 1 electron. So, it will gain 1 electron to become the stable. To become stable. அதனுடைய நிலைத்தன்மையை பெறுவதற்கு அதில் மொத்தம் எத்தனை இருக்கணும் எலக்ட்ரான் 8 எலக்ட்ரான் இருக்கணும். So it becomes stable. So when it will gain 1 electron to become stable, that is negatively charged ion. That is negatively charged ions with a negative valency of -1. With a negative valency of -1. Okay, children. My valency 7, if it is more than 4, if it is more than 4, that means 5, above 5. If it is above 5, it should be subtracted from 8. So the valency also 7 minus 8, the valency is -1. The valency is -1. So it will gain 1 electron to become stable. It will gain 1 electron to become stable. Negatively charged ion. Negatively charged ion. Okay, children. Now, chlorine plus 1 electron. It gain 1 electron. It gain 1 electron. So, it attains for attaining stability. So, is equal, gives rise to chlorine negatively charged ion. Chlorine negatively charged ion. Chlorine negatively charged ion. Now here, when it gains to 1 electron, 2, 8, 8. Yes? So 18 electrons. How many electrons? 18 electrons. Here 17 electrons. There 17 electrons. Did you understand, children? Are you listening? Okay. The next class, we will study the remaining portion. Okay, children? We will meet again. Now I will give the homework. Take homework note. All of you take homework note. Take homework note. Page number 41. Otherwise, book page homework. Listen, book page number. Book page 41. In that book page number 41, answer the following question in brief. Answer the following question in brief. Fifth question. Define. How many defines or define the following is there? How many definition they ask? 4. Define the following. In this define the following, 4 questions are there. That all homework. Okay. A to D homework. Okay, children. So, write the homework and send your homework in our school WhatsApp. We will meet again in the next video. Thank you all.